Hello, AP Bio students. It's me, Michael Wainwright, and my partner is Michael Groves, and we're going to bring you the Hardy-Weinberg equation today. It is an equation that definitely people have trouble on, but the math is not the problem. The variables are definitely the problem here. So we're going to spend a little bit of time kind of explaining those to you. Q squared is going to be the frequency of the homozygous recessive organisms in the population. P squared is the opposite of that. It's going to be the frequency of the dominant homozygous organisms. Q is going to be simply the frequency of the allele little d, which is the recessive allele. The frequency of the dominant allele is going to be P. 2PQ is the hardest part, and that is describing the heterozygous organisms in the population, or big D, little d, also known as carriers. The math is not a problem. As you can see here, the equations I have put in this video. We got some square roots here, which means or squares that we're going to have to use some square roots, but that's not a problem at all. So jumping into a example problem here, we have 23 red-eyed tree frogs, or a Calidrius, that are at Hardy-Weinberg equilibrium. Those 23 cannot change color to camouflage, and that trait is recessive. There's going to be 82 frogs in this population, and we need to know what percent of the frogs are heterozygous. So starting out, we need to find how many are actually or the decimal for how many are recessive. So we're going to divide 23 by 82 to get Q squared, which is the frequency of the homozygous recessive. We're going to get 0.2804. We're going to square both sides so we can find Q, which is the frequency of that allele. We're going to get 0.529, and the other, so we're going to subtract 1 minus 0.529 is going to give us P, because these two numbers added together has to equal 1, which is 100% of the alleles in the population. 2PQ is easy to calculate after you have these both a Q and P. We just plug it in and multiply it out. We get 0.498. We're going to move the decimal over twice to get 49.8%, since it's asking us what percent of the population is heterozygous. Now, if I can do this as fast as I am now, I'm sure you guys can do it, and I hope you have a great year in AP Bio. Thanks.